Once again, good morning to all. Good morning. Today we are going to discuss the chemical properties of the amines. Chemical properties of amines. Chemical properties of amines. First property, basicity of the amines. Basicity of amines. Second one, acylation. Acylation of amines. Third one, benzylation. Benzylation of amines. Fourth one, isocyanate. Okay, carbylamine reaction, carbylamine reaction. Next, carbylamine reaction. Next one is reaction with nitrous acid. Reaction with nitrous acid. Next, reaction with benzene sulfonyl chloride. The reaction with benzene sulfonyl chloride. Okay, so next electrophilic substitution reaction of the aniline, that is aromatic. Right, so these are the chemical properties we have to discuss. Chemical properties of amines. First one is basicity of amines. Second one is acylation of amines. Or in this category, alkylation. Alkylation of amines. Alkylation of amines. Third one, benzylation reaction or benzylation of amines. Carbylamine reaction. Reaction with nitrous acid. Reaction with benzene sulfonide chloride. So these are the common nucleophilic substitution reactions. These are the category of the nucleophilic substitution reactions of primary amines, secondary amines, and tertiary amines in aromatic and aliphatic amines. So we go to the details of all the reactions. That is a basicity of the amines, the first chemical property of the amines. Amines react with acids, form as salts. That is the fundamental, because amines act as a bases, and acid and base gives the salt plus water. We know the fundamental reaction. Basicity of the amines. See here, amines react with acids. React with acids gives salts. Gives salts. See the reaction. First, I am taking the NH3, ammonia plus HX. Ammonia plus HX. Ammonia is the Lewis base, and here acid HX. It gives NH4 plus and X minus. This is called the salt. Salt plus, okay, just salt. And water you won't get here because HX only. Next, if I take the primary amines, or NH2 plus HX gives, right, RNH3 plus X minus. This is totally is called the salt. Next, secondary amines, and secondary amines RNH, plus HX, it gives RNH2 R plus and X minus. So this is the salts. Last one, tertiary amine. Tertiary amine R, N, R and R plus HX gives, by SN2 it gives RN, R and R and H plus and X minus. Right. So these are the basicity reaction for the ammonia, primary amines, secondary amines and the tertiary amines. Ammonias react with any X equal HX is equal to any acid we can take like HCl, HBr and HI. HCl, HBr and HI. Right. So this is a example for the SN2 reaction. Means NH3 act as a nucleophile, primary amine act as a nucleophile, and the secondary amine also act as a nucleophile. Right, and tertiary amines also act as a nucleophile, and it donate the lone pair of electron to the hydrogen, and the X is leaved here. X is leaved. This is SN2 reaction. SN2 reaction. Then HCl, HBr and HI, the leaving ability of the HCl, HBr and HI is more here. Leaving ability is more for the I. That's why the reactivity towards the amines, secondary amines, primary and tertiary amines of the HX is HI is greater than HBr, HBr is greater than HCl, because I is a better leaving group. The reason is because I minus is a better leaving group. Better leaving group. So this is an example for the basicity of the amines. If all the basic amines, the basicity amines, we will get the salts here. R NH3 plus, R and R NH2 plus, R and R H plus are treated with a strong bases. Treated with a strong bases, we get the corresponding amines. So the salts are salts of amines. So the salts of amines. Salts of amines are react with strong bases like NaOH or KOH. NaOH or KOH gives corresponding amine means the reaction. Okay, that is the reaction is a reverse. Reversed. If I take the tertiary amine with the salt, tertiary amines salt, that is R3N H plus okay, no, plus NaOH. Right. So here X minus also here. X minus plus NaOH plus NaOH gives R3N plus R3N and H2O plus and NaX, sodium halide. This H and OH turned as a water, and X and X, NaX and R3N is as usual. So the salts of the primary, secondary and tertiary amines react with strong alkalis like NaOH and KOH. The reaction is reversed and the amines are get restored. That is the basicity of the amines and the reverse of that reaction. Next reaction number 2 is second reaction is second reaction alkylation alkylation of the amines. Primary, secondary, tertiary. Primary, secondary, and tertiary amines react with alkyl halides. Primary, secondary, tertiary amines react with alkyl halides, form a corresponding products. Form a corresponding products. Corresponding product. This reaction also proceed. This reaction also proceed in a SN2 mechanism. SN2 mechanism. SN2 because primary, secondary, tertiary amines act as a nucleophiles. Nucleophiles gives the lone pair of electron to the alkyl halide. So it is an example for the SN2 reaction. So now see the examples. Primary amine RNH2 plus Rx. So this lone pair is donated to this one. According to the SN2 mechanism, it gives NH2R plus X minus. So it lose one hydrogen and convert into RNHR plus HX. Because the positive sign is it lose one hydrogen plus X, we will get the HX here. RNHR. Next, R NHR plus Rx, alkyl halide, by SN2 mechanism, it gives the lone pair of electrons to the R. It will give RNHR and R plus X minus. So nitrogen is a more electronegativity, so it will never be the positive sign. Immediately lose the proton and convert into the tertiary alcohols. Lose it minus H plus and convert into R, N, R and R plus H plus, this X minus convert into the H, X we can write. This is tertiary amine. Alkylation of the primary amine gives a secondary amine. Alkylation of secondary amines gives a tertiary amine. And alkylation of tertiary amines gives quaternary ammonium salt. See here, R, N, R and R here, lone pair plus Rx gives by SN2 reaction R, N, R and R here, again R here and the positive sign. This is quaternary ammonium salt. What is the quaternary ammonium salts? Amines are considered as a derivatives of the ammonia, so that's it is called the quaternary ammonium salt. Now, steric factors affecting on the alkylation of amines. So this reaction proceed in the SN2 mechanism. So alkyl halide X must be a better leaving group. Alkyl halide X must be a better leaving group, then it favors the SN2 mechanism. Therefore, reactivity of alkyl halides towards the amines is equal to alkyl iodide is greater than alkyl bromide is greater than alkyl chloride. This is the reactivity order towards the amines, because I is a better leaving group. I is better leaving group. A better leaving group is a one. After its departure, it make a strong base. So this already we discussed in the SN2 mechanism. Already we know that. So better leaving groups favor the SN2 mechanism. That's why better leaving group. Yeah, any doubt, Amma? Tell me. What's your quaternary ammonium salt? Quaternary ammonium salt. Okay, na quaternary ammonium salt. And here x minus we take here x minus salt nothing but r plus n plus and x minus. That's why it is called the salt. Now reactivity of alkyl halides towards the amines. Ri is greater than RBr is greater than RCl region. Reason is I minus. I minus is a better leaving group. So leaving ability order. Leaving ability order is equal to I minus is greater than Br minus is greater than Cl minus is greater than F minus. F minus. Next factor. Factor number 2 for this for SN2 reaction of the amines. Factor number 2. So we know SN2 reactions are favorable. SN2 reactions are favorable for SN2 reactions are favorable for primary alkyl halides. Primary alkyl halides. Therefore, the reactivity order of alkyl halides regarding alkyl groups. That is primary alkyl halide is greater than secondary alkyl halide is greater than tertiary alkyl halide. And here we can write here methyl halide. Methyl halide is greater than primary alkyl halide is greater than secondary alkyl halide is greater than tertiary alkyl halide. This is called the alkylation of the primary, secondary, tertiary amines with the different leaving groups and the different alkyl groups. These are the conditions and the favorable condition for the alkylation of the primary amines and secondary tertiary. Is it clear, among girls? Is it clear to all? Only 11 participants are there. Next chemical property of the amines is benzylation. Acylation. Acylation means primary, secondary, and tertiary amines. Primary, secondary amines react with acetyl chloride. That is called the acylation reaction. Acylation means acetyl group is substituted in place of the hydrogen. This is called the acetyl group. Acetyl group or acyl group. So this group is substituted at the hydrogen, okay, in place of the hydrogen. That's what it is called the acylation. Right. Primary amines contain 2 hydrogens, so we can substitute 1 hydrogen with one group. Secondary amines contain 1 hydrogen, but tertiary amine doesn't contain the hydrogen. That's why tertiary amine do not undergo. Okay, no, tertiary amines do not undergo the acylation reactions and benzylation reactions. So for acylation reaction, what we require here either acetic anhydride or glacious acetic acid or any ester in presence of the pyridine, it gives the acyl reactions. See here that exactly we can write aliphatic and aromatic amines. Aliphatic and aromatic amines react with acid chloride, anhydrides, esters by nucleophilic substitution reaction. This reaction is called the acylation reaction. Right, see here, aliphatic and aromatic, aliphatic and aromatic, aliphatic and aromatic, primary and secondary amines, primary and secondary amines, primary and secondary amines, aliphatic and aromatic, primary and secondary amines undergo nucleophilic substitution reactions, in presence of acetic anhydride, or glacial acetic acid, or esters, Right, the reaction is RNH2 plus acetic anhydride CH3CO taken twice to O by pyridine, or else ester CH3COO C2H5. Right, so this acetic anhydride, the structure of the acetic anhydride is CH3 C double bond O C double bond O CH3. This lone pair is substituted here, that is NH2. Substitute here, this group is come this side, and CH3CO is substituted on the nitrogen, and acetic acid is a byproduct. So the product is RNHCOCH3, RNHCOCH3 plus acetic acid. This is a reaction. So reaction mechanism we don't require here. We know, okay, no need of the reaction mechanism. So just acetyl group is substituted on the hydrogen place. So this reaction is a SN2 reaction. Nucleophilic substitution reaction. Right, RNHCOCH3. If R is equal to in methyl group and CH3NH2 plus acetic anhydride, CH3CO taken twice to O by pyridine, or we can take acetyl chloride CH3C double bond OCl by pyridine, or ester CH3COO C2H5, ester. Any condition we can apply on the primary amine. It will give us CH3 NH C double bond O CH3. This acetyl group is substituted on the hydrogen, and plus acetic acid is formed in the reaction. If I take acetic anhydride, I will get the acetic acid. If I take acetyl chloride, I will get the HCl. If I take as usual acetic ethyl acetate, then I will get the ethyl alcohol C2H5OH. So these are the byproduct in the reaction. If I take acetic anhydride, byproduct is acetic acid. If I take acetyl chloride, byproduct is the HCl. If I take ethyl acetate or ethyl ethanoate, I will get byproduct is ethyl alcohol. Right. So name of this compound is N-methyl acetamide. N-methyl acetamide or N-methyl, base name is N-methyl ethanamide. So this is a reaction mechanism and the products. If we take secondary amines, let us take secondary amines RNH or and a lone pair plus acetic anhydride CH3CO taken twice to go by pyridine. Otherwise, acetyl chloride CH3COCl by pyridine or CH3COO C2H5 ethyl acetate. What do you get here? This lone pair is donated to the acetyl groups, then by the SN2 mechanism, or R and R here, COCH3 is substituted on the hydrogen. If I take acetic anhydride, I will get the acetic acid is a byproduct. And if I take acetyl chloride, HCl is a byproduct. If I take ethyl acetate, ethyl alcohol is a byproduct. This is a primary major compound. The name of the compound NN dialkyl acetamide. NN dialkyl acetamide, otherwise NN dialkyl ethanamide. NN dialkyl ethanamide. Here R is equal to, let us take R is equal to 2 ethyl groups CH3 CH2 N and CH2 CH3, here hydrogen, one lone pair, plus same condition I am taking CH3CO taken twice to by pyridine. Just I read only one condition. Then acetyl group is substituted on the hydrogen CH3CH2 COCH3 and here CH2CH3. This is the product. Byproducts are acetic acid. Byproduct is plus acetic acid. Name of the compound. Common name is NN diethyl acetamide. NN diethyl acetamide and IUPAC name is. So NN diethyl acetamide. IUPAC name is NN diethyl ethanamide. NN diethyl ethanamide. Girls, are you following me? Girls. So IUPAC name we can write here NN diethyl ethanamide. NN diethyl ethanamide. Tertiary amine. Tertiary amine does not undergo the acylation or benzylation because there is no replaceable hydrogen. There is no replaceable hydrogen. That's why tertiary amine doesn't undergo the benzylation and acetylation. Only primary amines and secondary amines undergo the acylation and benzylation because it has a replaceable hydrogens. It has a replaceable hydrogens. Next, benzylation. Almost time is up. Benzylation of primary and secondary amines. Primary and secondary amines. This reaction is called, benzylation reaction is called the Schotten-Baumann reaction. Schotten-Baumann reaction. Benzylation of amines is called the Schotten-Baumann reaction. So same method here. Primary amines, either in aromatic amines or aliphatic amines. Primary amines and secondary amines. Primary and secondary amines will react with benzoyl chloride. Benzoyl chloride and form a nucleophilic substitution products and form a nucleophilic substitution products. See here. This reaction is called the Schotten-Baumann reaction. RNH2 plus C6H5 COCl. This is called the benzoyl chloride. C6H5 COCl. This also we can write like this, C6H5 C double bond O Cl. This is benzoyl chloride in presence of the pyridine. In presence of the pyridine, right? It gives RNH CO C6H5. RNH CO C6H5. In place of hydrogen, the CO group is attached here. Right. N-alkyl. This is benzenamide. N-alkyl benzenamide. N-alkyl benzenamide. So R is equal to either R is equal to alkyl group or a aryl group, aromatic group. So R is equal to CH3 NH2 plus C6H5 C double bond O Cl in presence of the pyridine. It remove the H, just remove the HCl, means here lone pair is present here. This lone pair is attack on the C double bond O, and simply we can leave the Cl. Clear, ma? Is it clear to all girls? So then the compound is CH3 NH C double bond O C6H5. CH3 NH C double bond O C6H5. So name of the compound is N-methyl benzenamide. N-methyl benzenamide. This is a IUPAC name of the compound. If I take secondary amines, as usual, same method. If I take R is equal to benzene. Here also I am taking benzene here. For example, if I take instead of the methyl, if I take benzene, this is called the aniline. Aniline plus benzoyl chloride, C double bond O Cl in presence of the pyridine. It gives N-phenyl. Okay, N-phenyl benzenamide you will get. Right, this HCl is more here, then you will get benzene, NH, C double bond O, benzene. So this is N-phenyl benzenamide. Right, N-phenyl, N-phenyl benzenamide. N-phenyl benzenamide. This reaction is called the Schouten-Baumann reaction. If I take secondary amine with two alkyl groups, two same alkyl groups, CH3 CH2 NH CH2 CH3 plus C6H5 COCl. C6H5 COCl in presence of the pyridine, it gives C2H5 N, and here also C2H5 C double bond O C6H5. Right, this is called benzylation of the secondary amines. N diethyl benzenamide. N diethyl benzenamide. This is always the name of the product. Got it, Amma? Next, reaction with HNO2. This reaction is called the Sandmeyer reaction. That is a diazotization. If aliphatic amines are react with HNO2, it will give the benzene, diazonium salts. This already we discussed in the phenol chapter and carboxylic acid chapters, right? So RNH2, that is reaction with HNO2. HNO2 or NaNO2 by HCl at 0 to 5 degrees centigrade. That is 273 degrees Kelvin to 278 degrees Kelvin. Right. So this is a benzene. If R is equal to benzene, it is a benzene diazonium chloride you will get. So simplify general equation RN